Hey, honors pre-calc students. This is Mr. Mitchell here. We're going to talk about inverse functions today. So we got a few definitions here I want you to go ahead and fill out. So go ahead and do that. All right, let's take a look at some questions. It says, find the inverse function of f of x equals 4x. Then verify that both f inverse of x and inverse of f of x are equal to the identity function. So when we're finding an inverse, our first step is to make sure that it's y equals. Okay, so y equals, and then you switch the variables. And then you resolve for y. And we'll divide by 4. So y equals x over 4, or you can also write it as 1/4 x equals y. So this is f of x. And this is f inverse of x. So to do this problem, we need to do this first. We're going to take this function, and we're going to plug it into here. So I'm going to have 4x, and I'm going to sub in 1/4 x. I got 4 times 1/4 x. So what's 4 times 1/4? 1. So this is just x. So we're good so far. Now we got to do it the other way. We got to take 1/4 x and we got to sub in 4x. So that's going to be 1/4 times 4x. So 1/4 times 4 is 1. So it's just x. So they are inverses. That's how you verify. You've got to pay attention to directions. If you're asked to find the inverse, you just switch the x and y and solve for y. If you're asked to verify, you must do, this is g of f and f of g. You're doing Falun-Gong from a previous lesson. So we've got to make sure that we're aware of that. Okay? So now, which of the following functions is an inverse of 5 over x minus 2? So is it this one or is it this one? Well, we could do it a bunch of different ways. We could graph it and see which one is a reflection over the line y equals x. Or we can do it algebraically where we switch x and y. So I'm going to take this one and I'm going to transform it into one of those two, I believe is the best way to do that. So first, let's call y equals 5 over x minus 2. Then we got to switch the variables. So x equals 5 over y minus 2. I'm writing this over 1 because I'm going to have to cross multiply. So when I do that, I get x times y minus 2 equals 5. And then, well, I got to solve for y, so I'm going to divide both sides by x. I'm trying to get y by itself. So now I got y minus 2 equals 5 over x. And then I got to add 2 to both sides. And so there's my function. So it looks like my inverse function is letter B. Okay? And looking at it initially, I had an inclination that that's what it was, because this is a linear function. These are rational functions. They are not linear, so there's a chance, usually inverses are similar functions. So there's your inverse. I can write it in the proper inverse manner. This is f inverse of x. That's the correct notation, if you will. All right? So now we need to sketch the graphs of the inverse functions below on the same coordinate system and show the graphs are relations of each other in the line y equals x. I'm going to try my best here to graph these with this pen. So this first one's going to be in black. So I'm going to go down 3 and put my point. And then I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, and I'm going to keep going. Because I don't know how good I'm going to be able to draw a straight line here, so I might as well shade these points. I have to say, that may be one of the best lines I've drawn all year. Okay, so now let's draw this other line here. Got to graph this one. To use slope-intercept form, you're going to have to distribute the 1/2. So this is going to be 1/2 x plus 3 halves. So 3 halves is right about there, 1.5. So I'm going to have to go up 1, just right about here, over 2. Up 1 over 2. 1 over 2. Or we can go down 1, left 2, down 1, left 2. So, drawing the line the best I can. I think I need one more color. So it should be a reflection over the line y equals x. I will draw it as a dotted line if I can. So does it look like the black and the red reflect over this dotted line that I attempted to draw, which is y equals x? Yes. We could also prove it algebraically, but we do not have to in this problem. Okay, determine if the function has an inverse. That is a function using the horizontal line test. So, both of those are functions. We are told that. You could check using the vertical line test. It's f of x. It's f of x. You don't see f of x if it's not a function. So it is a function. It passes the vertical line test everywhere. Passes the vertical line test everywhere. So now what we're trying to do, does it pass the horizontal line test? Can I draw a horizontal line that touches the graph twice? For this one, no. Even right here, it only touches it one place. So the answer to this is yes. All right. Can I draw a horizontal line that touches the graph twice? Yeah, I can. So that means no, it's not. It's a function, but its inverse is not a function. So for this particular example, now we need to find the inverse. So first step, switch x and y. First, you got to call this y. You can do that step in your head if you like, but then it's going to be x equals 5 minus 3x, or 3y, I'm sorry, 3y over 2. Now you got to resolve for y. So multiply both sides by 2, cross multiply if you want to think of it that way. 2x equals 5 minus 3y. Subtract 5, so 2x minus 5 equals negative 3y. Divide both sides by negative 3. Be careful here, students screw this up all the time. So it equals y. You have to divide both things by negative 3. So it's going to be negative 2/3 x plus 5/3. You look at the initial function. This is a linear function, even though it doesn't look like it. You could divide both of those by 2 initially. This is a linear function. So it's a good chance that is done correctly. All right, so that is the inverse. Over here in letter B, we're going to say that x equals the square root of 2y minus 3. Again, I'm assuming that we have called this y first. So we've got to solve for y again. How do you get rid of a square root? Square both sides. Then you're going to get x squared. I'm just going to move over here a little further. X squared equals 2y minus 3. Add 3 to both sides. And then divide by 2. So y is going to equal x squared over 2 plus 3 halves. You can also call it 1/2 x squared plus 3 halves. But there is your inverse. All right. Well, that's how you find inverses of functions. And if you have any questions.